If you were absent and had to watch the video, then you've missed all the water demonstration, but we can at least skip through these. So just draw what you think it might look like. Okay. Now, again, when you see a question like this, you'll either have a picture of a vase and 4 graphs, or a graph and 4 vases to figure out what goes with what, or maybe it'll be a matching thing or something like that. But if you focus on the vase, you can figure out like where it's changing, right? So I start here and it gets skinnier till about right here, then it starts to get fatter again. So that's kind of where a change happens. So then the vase starts to get fatter till about right here, then it starts to get a little skinnier again, okay? So that tells me there's 2 times it changes, which means I should have 3 sections of my graph. You with me on that? Okay, so that can kind of help you narrow down what you're looking at. From here to here, as we fill in the water, the height is increasing no matter what. So this graph will never look like something like that. The heights, we're not dripping water out in this, anything like that. The height will have to increase the entire time. As we go from here to here, is the rate of change of the water increasing or decreasing? Increasing, because it's getting smaller. So as it gets smaller, the water, it fills up quicker, right? So increasing, then if it's going to change and get fatter, that means this has to be decreasing because it's not constant, which means then this increases again. And if you can figure that out before you start to draw it, then drawing it should be a little bit easier, right? Is increasing concave up or down? Up. So we're going to go increasing and then decreasing a little longer and then increasing again. Okay. Now, your graphs don't have to be perfect. I'm not even coming around and checking them. I just want you to put your thoughts down there. But the decreasing part should be a little bit bigger than the other 2 because of the size of the vase. Okay? Any questions at all? All right. Concave up, concave down, concave up. We all good so far? All right. Let's try the next one. Take that one, see what you got, see what you think about that one. I want everybody drawing something. You can hide it from your neighbor if you're insecure, it's all good, but draw something. And if it helps, maybe draw the vase so you can draw the lines in there too. Do you think there's any part in this vase where the rate of change is constant? No, it would have to look like a cylinder, right? So I don't think there's any place where it's constant. If I'm going to draw the lines in here like I did on the other one, how many horizontal lines would I draw? How many do you think? Like how many times does it change? 2. So to me, it looks like it's getting bigger till about right there. And then it gets smaller till about right there. And then it starts to get bigger again. Would we agree with that? Okay. So if I start here and it's increased, or the water's increasing no matter what, is the rate of change of the water increasing or decreasing? Decreasing, because it's getting bigger, right? So it's going to have more surface area to fill. So this is decreasing. Then it gets skinnier, which means it's increasing, and then decreasing. And when I say it, which I shouldn't be using that word, I'm talking about the rate of change, because the water is increasing the whole time. And we're going to do a lesson, it may be this week or the beginning of next week. We're going to talk about the rate of change changing, and I'm going to say the words rate of change and changing so many times your brain's going to hurt. And then I have to say it. We have to break it down and say it again, because you've talked about rate of change a lot. You have not talked about the rate of change changing, and that's what a lot of this course is about. And the words itself can just be overwhelming because you say it so many times it just sounds ridiculous. All right, so it's decreasing, which means that it's going to be concave down, then it's increasing, so it's concave up, and then it's concave down a little bit again. All right, so were you able to get your mind wrapped around that maybe a little bit? Okay. What questions we got? Anything? All right, let's try another one. We did a cone, but it didn't look like that. My cone was upside down, right? We did this. See what you think about that. Is the rate of change constant at any point here? No. The rate of change actually changes the whole time, but does it change from increasing to decreasing at all? No. So it starts off here, we're filling up, but then as we go, it's going to fill up quicker, right? So this is the one that looks like what kind of graph? Exponential. It's not necessarily an exponential graph, but it resembles one because it's concave up. I'm just trying to help you with the shapes there. Okay, concave up like a cup. And even though that doesn't, wouldn't hold water like a cup, it's still concave up. It still works that way. All right, what questions we got? Anything? All right, let's try this one. And maybe, you don't have that in front of you. You can always draw it to help you, or maybe you even write the words decreasing and increasing for yourself to help you with the curve, whatever works for you. But the more we can get our mind wrapped around this concept today, the more I think it'll help us tomorrow with the lesson. Do we think this one is constant at all? No. Okay. How many times will it change from increasing to decreasing or vice versa? Once. Okay. Oops. So I will draw my line here ish. So since it's here and it's getting skinnier, the rate of change is doing what? Increasing. And then since it's getting bigger, it is decreasing. What you don't want to do, and where I think sometimes the confusion happens, is you don't want to try and make the graph match the shape of the vase. Like those are not necessarily, related to each other like that. So if it's increasing, it is concave up, because remember, height is always increasing. The rate of change is increasing, and then the rate of change is decreasing. So we have a section that's concave up and a section that's concave down. And I'm going to throw another word at you that I don't necessarily expect you to remember, but at least you will have heard it when I say it again and we actually talk about it. When we change from concave up to concave down, there's a point there that's very important to us. We can't identify exactly where that point is in pre-cal because it actually requires calculus for us to find that specific point, but we need to know what it's called, and that's where concavity changes. That's called the point of inflection. Let me write that down. Inflection, just so that you can understand what I'm saying. It's not infection. It's not sick. There's an L in there. Inflection. The point of inflection is where we change concavity. Like I said, we'll talk more about this. We'll have notes and everything. Just want you to hear it and see it together today. Okay, we all good so far? All right. There's a couple more. I don't remember how many there are. Oh, no, that was it. My goodness. I finished way too fast in this class. All right, so let's do this then. You can go ahead and erase and put your markers back. We still have a few minutes, but I want to talk about a couple of things that I don't think I talked about in this class. So good job today, by the way. And so hopefully you got your mind wrapped around that a little bit. If you're still a little iffy, we're going to work on it a lot, so you're fine, okay? I don't know how I got through this so much quicker, probably because I already did it. But so I told you that the AP exam is multiple choice and free response. So on the free response, there's lots of writing. It has to be like specific writing and specific explanations. Calculator and non-calculator. So we are not checking calculators out to you. Last year, Desmos became part of the AP exam, and they told us that at the last minute, and then Desmos changed a whole lot during the year. So that's why this sign is up here, because there's some days we'll be on Desmos and sometimes we won't. So that's kind of, so just what we know what we're going to have. But we can do it. Y'all are probably actually a little bit more skilled at Desmos than I am, because you probably used it longer and more. But there's a lot of things that have changed over the last year and added specifically for AP Pre-Cal and for calculus that you may not even know is there. And we'll look through those things. So you don't have to worry about a special calculator or anything like that. It'll be on Desmos. But it's not, you don't get it for the whole test. You get it, half the test is calculator, half of it's non-calculator. So there are things that we do where we have to know how to do it 100% with no calculator, but then we also have to know exactly how to use the calculator or Desmos correctly to get what we need. And some of it we have to know on both, some of it's just one or the other. So there's still lots of skills that we have to be able to do the non-calculator stuff. Some of that, which was all in the instructions in the summer assignment, was knowing your multiplication facts. Those are important. We were working on fractions last period in college algebra, and one of the things that was messing people up was not the concept of fractions, is that they didn't know their multiplication facts, so they couldn't find the common denominator right. You know why a lot of you struggle with factoring is because you don't know your multiplication facts, so you can't come up with the correct numbers. Okay, so those things are more important than you realize. And just because you can do everything great on a calculator, great, but you're not going to be able to have 100% of the time. Okay, so any questions about that? We good on all that? All right, so make sure if you didn't get logged into AP Classroom that you make that happen. Hopefully you all did everybody get into Google Classroom just fine? Like that shouldn't have been a problem. But I know some of you might have run into a roadblock of an AP Classroom. If you keep having problems and you need to talk to me about it, let me know and we'll figure that out. Okay? Anybody got any questions for me about anything? ISNs go with you. They come back every day. They will be graded every time you take a test. Okay? And I'm really looking for, did you take notes? Are they in there? Because then you'll have everything all year and it'll be good for you. Okay? We good? All right.